All right, we're jumping into our next topic, which is planes. So we've so far looked at vectors, which obviously are just and lines in this space. But we're now jumping into planes. So by definition, we've looked at points, which are one-dimensional. We've looked at lines, which are two-dimensional. We've talked about planes and space, but we're now going to look at planes a little bit more in depth. Now, the ones we've looked at the Argand plane and the Cartesian plane are our two main ones. So if we have 2 points, say we have A and B, and they lie on a plane, we say that AB is parallel to the plane. So previously when we've defined parallel lines, we've talked about a line being parallel with a line. We are now saying that it's parallel with this plane. And so with this definition, we can look at, well, if A and B here, I've drawn it parallel with this side of the plane here, a parallel with the plane. We've also got AC here as parallel with the plane, but AB and AC aren't parallel. So a vector is parallel to a plane if by traveling along the vector, we remain on the plane. So that should make sense to us. So it's a bit like in the Cartesian plane, we use X and Y because we never come off that plane. Our Z component never changes. So AB and AC are parallel to the plane, but not each other. So they're not parallel to each other. And it's important to realise that A and B intersect. So AB and AC are not skew lines. So they're are not, I'm just going to write are not skew lines, but the direction vectors aren't skew. They go through each other. They start from the same point. Now, with this definition here, if we wanted to come up with a vector equation for a plane, this isn't in the SACE course as well. I'm just going to quickly talk about it. If you consider this A point here, if we were to go along it with a vector that's parallel to the plane or another vector that's parallel to the plane, as long as we've got this fixed sort of reference point, we can go out along with these vectors. We can multiply V by any value of S and we still stay on the plane. So this equation keeps us on the plane. All right. Now, you'll notice in the text I've missed another formula, but it's not actually part of our course, so I'm running a bit quicker. So the normal of a plane, so a vector is normal to a plane. So we're thinking of, so when we had tangents, that we have tangents and normals. This is sort of the same thing. Our parallel line, we're looking at the perpendicular line for that. We're looking for our normal to a plane, which means perpendicular to that plane. So a vector is normal to a plane if it is perpendicular to all vectors which are parallel to the plane. So we've got this thing here, the normal vector. If we have two vectors that sit on the plane and we do the cross product, we're going to get the vector that's parallel to that, which we've done previously. So now this is the important bit. The Cartesian equation of a plane is the one we're going to use. So the Cartesian equation of a plane, if a plane has a normal vector, so say you've done the cross product of the two vectors and you get the normal, and it's got these components A, B, C, and it passes through a coordinate, X, Y, and Z. So I've written that's a coordinate, or we could write it as a vector. Then it has an equation, AX plus BY plus CZ equals A. Now, maybe I'll highlight these just to make them a bit clearer. So this A is the same as this A, which is that A. We've then got our next one here is B, B, and B. And then our last one here is C, C, and C. Now, the point of this is we've got here, this is going to give us an equation. This here, these three things multiplied together will give us a constant, which will be D. Okay, so let's look at an example of this. So find the equation of the plane with the normal vector 1, 2, 3, which passes through the point -1, 2, 4. So straight off the bat, looking at the one above it, we've got, well, I'll write this out twice just so we've got it. So we've got AX plus BY plus CZ. And you got to remember that equals 1, 2, 3. So we've got 1x plus 2y plus plus 3z. And these are going to equal A, and then the coordinate, the x coordinate, plus B, the y coordinate, plus C, the z coordinate. So we've got them, which is going to be, we're going to have 1, 2, 3, which was our ABC. And now we've got these values over here. So -1 is our x-coordinate. So we've got -1. We've then got 2 and 4. So this is going to equal D, which will be -1 plus 4 plus 3. But let's do it here. So we're going to have -1 plus 4 is 3. And 3 plus 12 is 15. Okay, so that equals 15. So then our equation for our plane is x plus 2y plus 3z equals 15. And that's all done there. So that is the Cartesian form of the equation. So I'll just stop there. I'll do another example in another video. Thanks.